Hi folks, this is part 2 of the exponents investigation. So here we're going to try to figure out what's going on with negative exponents. So here, first thing I'd like you to notice, or hopefully you notice, that these two expressions in part A and in part B, for each one of them, are actually the same. So here I've got 7 squared, 7 times 7, and in the denominator 7 cubed, 7 times 7 times 7. So whatever expressions these two are equal to, they themselves should also be equal. Okay, so here let's use arithmetic. So hopefully you saw similar to what we did in number 2 above. So here, well, 7 over 7, that reduces because it's the same factor. Now remember, it has to be a factor, meaning a multiplication. Same factor in numerator, denominator, so I can simplify this fraction. So I'm just left with a 1, because that's what 7 over 7 is equal to. Same thing here, 7 over 7 is equal to 1. So in the end, I'm just left with 1 over 7. Okay? But now, if I apply the exponent laws to this expression here, 7 squared over 7 cubed, so same base, I can subtract the exponents. I'm left with 7 to the negative 1. That tells me that 7 to the negative 1 must be equal to 1 over 7, since these two expressions were themselves equal. Okay? So before making any conclusions, let's go on and see if, what happens when we look at a similar example. So here, these 5's simplify to 1, these 5's simplify to 1, these 5's simplify to 1, and we're left with 1 over 5 cubed. Notice how I'm going to leave it in power form, because I am trying to look for some kind of pattern here with the exponents. Now here, if I use the exponent laws, same base, so I subtract 3 minus 6 is negative 3. So we see that 5 to the negative 3 has to be equal to 1 over 5 cubed. So hopefully now you're starting to see the effect of this negative exponent. Okay? As a last example, let's look here. So we got whatever number this is, I'm dividing it by itself, so it's just equal to 1. Same thing here. Same thing here. So we're left with 1 over x squared, and when I apply the exponent laws, I get x to the negative 2. So from here, we can judge that the effect of the negative seems to be to create the reciprocal. Okay, so it looks as though if I have x to the negative n, that's just equal to, so it creates the reciprocal. Okay, and what I'm left with in the denominator is just the positive version of that exponent. Okay, and in particular, the special example would be x to the minus 1 is just equal to 1 over x. Now this is very interesting, because this tells us that the reciprocal function that we studied can in fact be considered as a function with an exponent. Okay, that 1 over x is equivalent to x to the negative 1. Okay, so now we've got all the positive integer exponents and all the negative integer exponents accounted for. Okay, so the only integer that's left is 0. So that's what you're going to look at. And I'll shut it off and give you a few minutes to look at number 5, where you're going to try to figure out the meaning of a 0 exponent. Okay, so take a few minutes to finish this up. Okay, so let's continue where we left off, and now we're going to try to figure out what the 0 exponent means. So here again, I'm creating an example that'll result in a 0 exponent. So I have 25 over 25, which I've also written as 5 squared over 5 squared. So why did I write it as 5 squared over 5 squared? Because I need to create this 0 exponent, and so I know that when I divide two powers with the same base, I can subtract the exponents. So this here, I'll go backwards here, leaves me with 5 to the 0. But 25 over 25 is equivalent to 5 squared over 5 squared. And of course, when I take a number and I divide it by itself, I get 1. So what this tells me here is that 5 to the 0 has to be equal to 1. Now, is this just a coincidence for base 5, or is it something we would expect to find in any scenario? So here we'll create another example. So if I take 27 over 27, which is the same as 3 cubed over 3 cubed, I get the same thing going on. This just becomes 3 minus 3 is 0. And of course 27 divided by itself has to be equal to 1. Okay, so now that we know that x to the 0 has to be equal to 1, and we'll talk about whether that will work for any x value, okay, when we put everything together, but it seems that this is the result we're getting. So now, based on 4 and 5 and what we already knew about exponents, we now can determine what every integer exponent means. So the next video, we're going to take it one step further. We're going to see what does it mean to be a rational exponent. Okay, so that'll be in the next video.